Welcome to this short presentation of NMDG, a partner of Rohde & Schwarz, who is selling and developing applications running on Rohde & Schwarz vector network analyzers. These applications are bringing the capabilities of the Rohde & Schwarz network analyzers beyond S parameters. The applications will allow you to reveal the large signal behavior of your RF components. And you can do that with incremental investments, increasing the capabilities of your network analyzer step by step. First of all, it is possible to perform source pull and load pull measurements with your network analyzer, allowing you to characterize your devices in a non-50 ohm environment. This sounds curious because normally a network analyzer operates in a 50 ohm environment, but taking advantage of the fact that Rohde & Schwarz vector network analyzers have two sources inside the network analyzer, we can actually perform actively source and load pull. It is simple, as you can see in the setup. It is accurate because it refers back to the network analyzer calibration techniques. It is fast because we are using basically the capability to electronically control the amplitude and the phase of the internal sources. And also, the source and the load pull can be applied across the complete frequency range of the network analyzer. The devices under test can be either in fixture, they can be connectorized, or can be on wafer. For on wafer, the advantage of the active approach also is that there is no mechanical structures required to mount, for example, tuners on the probe station. The only thing that needs to be done is connecting the network analyzer to the probe station. With an incremental investment, it is possible to gain further insight in the behavior of your components. With this incremental investment, it is possible to look at the time domain waveforms at the input and the output of your device under test. So, for example, you can look easily at compression characteristics of an amplifier or pinch-off effects of a transistor. It's also possible to show this information in the frequency domain. And because with this incremental investment, you do have the voltage and the current waveforms both at the input and the output of the device under test, you can actually measure and represent impedances both at the input and the output of your device under test, which is very convenient for optimal matching of transistors in your amplifier design. Additionally, it is possible to have a look at the dynamic load line and to visualize on the fly, almost in real time, derived quantities from this voltage and current behavior of your transistor or amplifier or device under test, like for example P delivered in, P delivered out, power added efficiency, gain, and so on. The incremental investment consists of additional software that is required running on the network analyzer or on a separate PC, and some hardware that basically turns the frequency domain capability of a network analyzer into time domain capability of the network analyzer. Where is this capability used? Well, first of all, it is used to get better insight in the nonlinear behavior of devices. Nonlinear devices are, for example, diodes, transistors, can also be multipliers, dividers, and amplifiers. Another reason to use this capability is when you have design kits in your simulation tools and you're not sure about the quality of the models in the design kit, it is easy to use this capability to verify and in fact also improve the models. Another reason why to use this capability is for the reliability testing of your devices. Often reliability is done with DC measurements only, but now it is possible to do it under RF realistic conditions so that you can actually see your devices breaking down and possibly restoring from the breakdown. And another major area of this measurement capability is basically to use the waveforms that can be visualized now as basically amplifier design tools. As the power requirement of the devices under test is going up, for active injection, the power requirement of the sources inside the network analyzer would also go up. And at a certain moment, it makes much more sense to actually use passive tuners. So the software used for active source and load pull can be extended with passive tuning capability. The use model is staying exactly the same, but instead passive tuners are being used for the source pull and the load pull. It is also possible to make a hybrid, make the combination between the use of a passive tuner and then take advantage of the active tuning to very fast explore the device behavior around a pre-matched source point or load point. Additionally, it is possible to extend the integrated component characterization environment with pulsed capability. One can add DC pulsing capability by integrating the focus DC pulsars and combining with a Rohde-Schwarz oscilloscope to visualize the DC voltage and current pulses. For RF pulsing capability, one requires an additional box going underneath the Rohde-Schwarz network analyzer. This box is called the Rohde-Schwarz ZVX box. It contains, amongst others, RF modulators that basically are pulsing the incident RF power. Source and load pull measurements lead typically to lots of data that needs to be interpreted to be able to do an amplifier design. Unfortunately, the data cannot be used in a simulation tool to simulate your device under test in conjunction with additional circuitry that will go around your design. S-functions will remedy that problem. S-functions are the S parameters for nonlinear components. So it is possible to extract with a measurement setup S-functions of a device under test and then basically feed these S-functions into a simulation tool. NMDG is providing, besides the extraction capability of S-functions, also a tool for easy verification of the quality of these S-functions. For low power and medium power devices, it is even possible to use the active source and load pull as the verification tool of the S-functions before these S-functions are being fed into the simulation tools for design purposes. Today, we do support two output formats. We basically are able to export the S-function models into MWO from AWR and into ADS from Agilent Technologies. This concludes a short presentation on the incremental applications that can be added to the Rohde-Schwarz network analyzer to step-by-step reveal the nonlinear behavior of your devices. It has been shown that active source and load pull can be performed, that it is possible to combine it with passive tuning capability, to do this under DC and RF pulsed conditions, to add software and hardware to be able to visualize the waveforms at your device under test, which is very useful to get more insight in the nonlinear behavior of the devices. And finally, we have shown that it is possible to extract nonlinear behavior models that can be used in ADS from Agilent Technologies and MWO from AWR. For more information, you can contact your Rohde-Schwarz sales representative. You can also contact an NMDG representative, or you can email us at info@nmdg.be. You can also visit our website www.nmdg.be. Finally, I want to thank Rohde-Schwarz and Focus Microwave for the excellent cooperation that made the realization of these applications possible. Also, I want to thank Agilent Technologies and AWR for the support, for the license support for ADS and MWO. Thank you very much. Bye-bye.